All right, ready for our last lesson? Okay, so this, like I said, this warm-up was actually not even as bad in terms of difficulty level as the homework because your roots were nice, right? What do I mean by nice? What do I mean? Yeah, they gave me all three roots on the graph, right? I didn't have to do any, and they weren't radicals, and they weren't like imaginary, right? And I know it's cubic, so I got all my roots, right? My roots are -3, -1, and 2, right? If I know my roots, I know my factors. I'm going to kind of just skip to writing in factored form now. So I have f of x equals, you could write y as well, that's why I went well. And then -3 becomes x plus 3. -1 becomes x plus 1. 2 becomes x minus 2. And on your test, there's many different versions of problems, right? This might be a problem right here. Here are your roots right in factored form. You're done. So make sure you're reading what it is. If it doesn't ask for standard form yet, don't give standard form. That's more opportunities for mistakes, right? Also, it shows you're not looking at the question. But then you might get another problem that says, okay, now write it in standard form, okay? And to do that, you got to multiply it out. What is that times that times that, okay? So you have f of x equals, and then you would do this times this. Again, you would FOIL, you would box, right? I'm going to just give you the result. Don't write it down in your notes thinking that you should be able to do this in your head. I'm not expecting that. But I do want to make sure we focus on the new skills. This times this, right, is x squared plus 4x plus 3, right? And then I bring down the other one. Okay? Now I have a 3 times a 2, right? 3 and 2. 1, 2, 3, 2. That's when we use the box, or at least I like to use a box. Some students don't, but I recommend it. This we haven't done as much, so I'll do it, right? You get 3 boxes on the top, 2 boxes on the side. And I have x squared, 4x, and 3. And I have x, and I have minus 2. And I do every box, right? I end up with x to the third plus 4x squared plus 3x minus 2x squared minus 8x minus 6. This one does turn out to be a nice diagonal situation. Or with my like terms. It's not always going to be the case, but this one was. So that means my answer is f of x equals x to the third plus 2x squared minus 5x minus 6, right? Boom. Followed the steps Mr. Patron gave me. I'm solid. I know I got the right answer, but I know enough about this stuff to check my work. And I look over at the graph and I say, wait a minute. What did I do wrong? Because something here doesn't make sense. What doesn't make sense? The y-intercept. What would be the y-intercept we would expect based on what we've learned so far?
-7.
Right. Isn't c supposed to be our y-intercept? And what do we see on the graph?
It's -10.
-12. Doesn't match. So what do we do, or what might be happening here? And I heard somebody say the thing. Now, there's something we have not yet talked about, except for me to tell you that it's 1, because I didn't want you to worry about it until now. The last piece of the puzzle. What have we not talked about in these functions? Like, think back to a quadratic. What was always really important, but we really haven't dealt with it? A. Yeah. We haven't talked about stretching at all. We haven't put anything in front. Everything we've looked at would be like x to the fourth, x to the third, right? We haven't done 3x or 1 half x to the 4th, something like that, right? And that'll happen, of course. Of course there'll be situations like that, right? So that's our last piece. That's what we're going to do. Now, think, why is it possible for there to be another a, even though we did all the right math?
Just times 2 it, and it will be.
Well, that's a good prediction. Maybe it'll be times 2. But I'm talking about, why is it possible? Like, why could everybody in this room could do this and get a different equation and all be correct based on the directions they were given? Thinking about, what does an a do?
Direction or
It stretches or shrinks, right? Okay, so we didn't do anything wrong, right? But think about this. If the graph looked like this, oh, come on. There we go. Wouldn't you do the same exact thing? You would take your 3 roots, you would get the same answer. You still wouldn't have -6, right? And I could do this 5 more times. I could do this a bunch of more times, right? And I could keep getting different graphs that have the same roots, right? The roots are not affected by the a value, right? So it means we need more information, right? We have not been given enough, and today we will be given one more piece of information to find the right a value. Because I don't want everybody having different equations. I want you all to have the same equation when we ask you for an equation, right? Okay, so I heard some people predicting what they think this a value might be. What do you think? 2. Why do you think 2? Right, we had -6. Graph had -12. Well, maybe it's just times, you just have to multiply by 2, because that's what stretch does, right? But I will say this. We'll test it to find out. And by testing it, we'll come up with a method so you can find your a. Because what if your a was 1/7, right? Well, that wouldn't be easy to see on a graph. So you need a method to find it, right? So we'll do the method with the one that we think we already know, and then we'll use it on harder problems, okay? So basically, we're all saying, we're asking ourselves, is a equal to 2? Well, let's prove that it is, if it is, okay? And how do we do that? How do we prove anything in math in this class?
just
Do it. What do you mean, do it?
put it in and solve it.
Okay, that's kind of a guess and check, but that won't help us with other problems. How do we set up a process that we could use even if a was like 1.2?
I mean, didn't we do when we just did the quadratic?
Mm-hmm. It's
stuff?
very similar.
We
Yep.
did, I don't quite remember the equation, but there was like a method to find the a.
There was, and it's going to be the same method.
Just like he would like kick out the c's.
No, that's completing the square.
Oh.
But you're on it. Like we can find our a. We can solve for a.
I don't quite remember.
Right?
The process.
A is an unknown value in math. We can solve for unknown values if we know all the other values, right? So think about what we know. We know our factored form is this. Y, let me make this a little bigger. Y equals, do we know our A? No, when we don't know an A, we don't know anything in algebra, what do? Just put a letter in for it. Leave it there. We'll figure it out later. And then we know the factors. We know x, what was it? Plus 3, x plus 1, x minus 2. Okay, so we can't find a in this situation because there's a pesky y and x in there, right? And when you have 3 letters in an equation, you can't solve for one of those letters. So if only we had something we could put in for x and put in for y, then we could solve for a, and then we'd know our a. Yeah.
We already have a thing to put in for.
What is our x and y we can put in?
I mean, x would be one of the. I mean, if you were doing the 0.
Here's the exception. If you use an x-intercept, it'll make everything 0. So that won't help us. It'll like be a times 0, and then a will go away. So the only thing we couldn't use is an x-intercept.
Well, I don't know how you would get the x, but for the y, you already have the y-intercept.
Okay. What is a y-intercept? So our y-intercept is what? It's negative 12. What is a y-intercept?
A y-intercept
Just-
is when the
It's a what?
it's when
It's a point.
it's a point when
What is a point made up of? Every single point has
y
an
and
x and a y.
the x
What is a y-intercept? Not just negative 12. Give me the whole point.
0 and negative 12.
0.
That's a point we know, right? That's a point we know on the graph that we can plug in.
So we put 0 instead of 12.
So instead of y, I'm going to put negative 12. I don't know a. That stays there. Instead of x, I'm going to put 0 plus 3, 0 plus 1, 0 minus 2. Now, it looks a little weird right now, but we've accomplished a goal. A is the only thing left. We solved for it. We can do the little math here. Negative 12 equals a times 0 plus 3 is 3. 1 minus 2. So that's, 3 times 1 times negative 2 is negative 6. So we have a times negative 6, but we put the number in the front, right? So it's actually negative 6a. So negative 12 equals negative 6a. Now I solve for a. I divide by negative 6. And I get a equals 2. So now we have a process, right? We know what we can do every time. Remember I said there was a missing piece of information? Well, that missing piece that you will be given every time is a point. It might be a y-intercept. It might just be a point. All right? So we need to be able to plug it in for x and y, find our a. Okay? Sometimes our a's will not be as obvious as 2. So we need to be able to use the strategy.
Oh, that's it. Can't we just guess?
No. What if it's like 1.76? I don't know. Right? You've got to be able to solve for it. Right? All right. So let's write down some steps real quick. And then we'll do a couple problems, and then you will have your weekend. Okay? So our steps that you want to follow every single time is 1, set up factored form. With a in front. Okay? So you're doing your factored form. You're leaving a place for a. We're not assuming a is 1. Okay? Then plug in your x, y values from the given point. You'll always have a point. It might be on a graph. It might just be words that says, hey, here's a point that's on this function, right? 3, solve for a. Now, here's where a lot of students lose points. They do all the right work, and they find a, and they circle a, and they walk away from the problem. But what are we trying to do? We're trying to write an equation, right? A was a piece of the puzzle. We found it. Now put it into the equation. So step 4 is write your equation. With the found a. Okay? Don't forget to finish the job. Okay? So those are your steps. And just pay close attention. If it asks for factored form, leave it in factored form. If it asks for standard form, go all the way. Okay? Now, what you need to do is what we did last class, but then you solve for a. Okay?
Wait, so we write the equation with found a, so we just write the equation, but instead of like, we just put 2 in.
Well, you'd put 2 in the front, but not just in the front of standard form, in the front of factored form, and then you would.
Then I have to do it again to standard.
Well, you just can't throw an A out front. You have to distribute it through. That's the other mistake people make.
Wait, so put.
You're going to see in the example. You'll see. We only have a little bit of time. I guarantee you'll see it. Okay? So it says write the equation of a cubic function in standard form. It has roots of 2 and negative 3i. It also has a y-intercept of 36. When you have that also piece, you know you're looking for a. Okay? Now, y-intercept of 36, we have to be smart enough to know that's a point. That point is what? 0, 36, right? That is our xy. Okay? Then we set up our equation with our roots. We know we have f of x. Well, actually, I'm going to go y, since we're going to be plugging in for y. Y equals a, don't know what a is, so I'm going to leave it there, x minus 2, x plus 3i, and what else? X minus 3i, right? Because we know plus 3i and minus 3i go together. Okay. Now at this point, you plug in. Don't try to turn it into standard form yet, because it's going to be a lot harder to plug in standard form than just these little easy parentheses. Okay? All right, so we had 0, 36. So we say, okay, 36 equals a times 0 minus 2, 0 plus 3i, 0 minus 3i. When you get 0, it's really nice because it just all becomes very simple. 36 equals a times negative 2 times 3i times negative 3i. And again, if it helps, pretend they're x's, right? It would be negative 2 times 3 times negative 3, and then you'd have I times I. So what does that all become?
That becomes 36 equals a.
Let's just do one at a time. Negative 2 times 3.
That's 6.
Negative 6.
Negative 6.
And then negative 6 times negative 3.
Negative 6 times negative 3 equals
18. So we have 18 and then I squared times a. What do we know I squared is?
Negative 1.
Negative 1. So really we have 36 equals negative 18a, divide by negative 18, divide by negative 18. A equals negative 2.
Wait, but then isn't it positive 18 because it's negative 1?
Where's negative 1?
I squared.
Yeah, but it was positive.
Oh.
Positive times a negative is a negative. Okay, so this is where the mistake 1 happens, where we do all this really good work and we feel really good and we move on to the next problem. I did not ask you to find a. That was not the problem. I wanted you to write an equation. In fact, I want you to write it in standard form. So let's keep going. Okay, now that I know my a, I write it again. I say, okay, f of x equals negative 2 times x minus 2, x plus 3i, x minus 3i. And now we kind of go into last night's homework in the last lesson. Okay? I got to be able to multiply this out. And then one thing I want you to write down is distribute a last. Do not distribute a right now. It'll cause you to miss some stuff. Okay? So what does that mean? Well, it means I'm going to worry about this part first, and at the very end, I multiply by negative 2. Okay? So, again, this is last lesson, so I'm going to be skipping a little bit around here. But what you would have is x minus 2, and then this whole thing, I'm not expecting you to do it in your head, right? I'm just going to do it now because we already covered it last lesson. It would end up being x squared plus 9. Okay? That's what those two become. And then this whole thing becomes f of x equals negative 2. And then this times this becomes x to the third minus 2x squared plus 9x minus 18. Okay, now the other big mistake people make is they just find this and then put a negative 2 at the front and they say I did it. What's the problem with that? You have to distribute. And the way you can check is if I did that, I wouldn't have the right c value, right? So now I distribute, boom, 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 4 times. And I get f of x equals negative 2x to the third plus 4x squared minus 18x plus 36. Now, how do I know I did this right and I didn't make a mistake? 36 was the y-intercept, so that should be my last number. Question? I did that in my head. Remember I said, I don't expect you to do this in your head, but in the interest of time, I have to do this in my head right now. But you would FOIL that out. That was yesterday's lesson, okay? You have 6 minutes. There's one more problem that you're going to do, okay? It's similar, and then I'll hand out your homework while you're working on it, and then I'll just show you the result at the end. Now, remember to read the instructions. This one asked for standard form, so we had to go this far. The next one only asks for factored form, so don't go too far, okay? All right. And I'll just help you a little bit to not fall into a trap here. Now, this is your point, right? That's your x, y, right? What are your roots? Negative 4. Negative 2. And?
1. But I have a question.
And?
1.
1 again. That's a double root. So this is a quartic function, okay?
What?
It bounces, right? So make sure you put 1 twice when you're doing your work, okay? All right. So here's the key thing here, right? So you're going to write a polynomial function in standard form that has given roots, right? So I'm going to show you my process. You might be able to skip some of these steps because you don't need to be listing things or whatever. But maybe you want my process, right? Because this is kind of going to make sure you can flow with the logic that you're doing, okay? So we have a polynomial function. We need it in standard form. Now, a lot of the trip up here that students have is they're like, well, I know standard form is like to the third, to the second, like it's that long expanded thing, right? How do I get to that just from roots? Well, you really can't. You have to go to factored form, then go to standard form. So don't, even if it says go to standard form, you still got to go to factored form first, okay? So I like to list my roots. So I have a double root at negative 4. What does that mean?
Negative 4.
That's 2 negative 4s, right? So negative 4 twice, and then I have a root at 3i. Okay, so is this a cubic function with 3 roots?
No.
No, why not?
Because I used to have 1 missing.
Yeah, so I will always have a plus or minus. So even though they didn't say there's a minus, I know it's impossible for there not to be a minus. So I actually have 4 roots here, which means I'll have 4 factors, which means it will be a quartic function, right? It should end up being to the 4th at the end. And if we list our factors, well, all we do for our factors is we go x and we flip the sign, right? And I want you to know why, but that is the skill, right? Plus 4, plus 4, minus 3i, plus 3i. Okay, so you've got your roots, you've listed your factors. You've already shown a lot of knowledge, by the way. So if you get this far, that's great. And like on a test, if this is all you know to show, do that. Don't leave it blank because this shows me some understanding, okay? Now, what we want to do is write this in factored form, right? Well, we have factors. What are factors? They are things that multiply to give us bigger things. So the factored form is just multiplying all the factors, right? So I guess I'll go down here. We would say, okay, factored form, f of x equals, and then, well, if these are my factors, that times that times that times that. So x plus 4 times, but I don't have to write times, we just put it next to it. X plus 4, x minus 3i, x plus 3i. Okay? Now, when we're doing this, we have 4 things that need to multiply. Got to multiply that, and that, right? We've talked about this a bunch of times, like you don't multiply everything at once. You don't try to, just pieces at a time. Now, I will say that there are better pieces to multiply than others here because you don't want to mix up the different types. Like if you keep the i's together, if you keep the numbers together, it's going to be a lot cleaner, right? It's not impossible, but it'll be cleaner. So I want to multiply this and this, and I'll multiply this and this, figure out what those are, and then multiplying by each other, okay? So the first thing I'm going to do is to multiply this by this, okay? To do that, I would box or FOIL. We've been doing that a zillion times, so I'm just going to assume that we are okay with box or FOIL. If not, we can come for help, okay? So this times this, I'm not expecting anyone to do this in their head. This is just what it would be, okay? That becomes that, okay? This one I'll show you the process because this is the tricky one, right? If I want to know what this times this is, what this will become, right? If we multiply these two together, well, if we think about FOIL, it's first, outer, inner, last. So, okay, first is x times x. That's pretty standard. That's x squared, right? And then this is where we get a little weird because outer is that times that. So I have plus 3i times x, right? I don't know how to do that. Like, when we don't know how to do something, like when I have 3 times x, I just write 3x, right? I write 3 times x because I don't know what x is, so I just write 3x, right? Same thing here. I don't know what 3ix is, so I write 3ix. You just write what you have, right? You can't combine any of that, right? Just write it. Hopefully it'll go away at some point. All right, the next one, negative 3i times x. Well, again, the best I can do is just write that, negative 3i times x, okay? And then lastly, negative 3i times positive 3i. And people get a little tripped up here, but the same people who get tripped up would be able to do this. They would be able to do negative 3x times 3x, right? Those people would have no problem with that, right? It's the same thing. I is a variable. It's just a letter. It gets treated just like anything else. It stands for something. It's holding a place, right? Just like x is. If you have negative 3x times 3x, well, negative 3 times negative 3 is negative 9. And then x times x is x squared. Same principle over here. I have negative 3 times 3, that's negative 9. And then I have I times I, that's I squared. Right. And if you want to do this all in one step, you can. But I want to show the steps here. All right. So now I'm going to clean that up over there before I try to multiply anything. I'm going to look at what I got. Now that 3ix thing, there's good news every single time because we didn't know what to do with that. But if I have positive 3ix and I have minus 3ix, that's like having plus 3 and minus 3. If you had plus 3 minus 3, that's 0. That just goes away, right? It doesn't matter that it looks weird. It's the same thing, positive and negative. That goes away, right? Nice, gone. Okay, and then I have negative 9 times I squared. We'll talk about that as we bring this down. Okay, so I have f of x equals, bring this part down, x squared plus 8x plus 16. Here I have x squared. Now, negative 9 I squared. Let's think about this for a second. And this is something you just got to know. Like, we don't have to memorize a ton in this class, but this is one thing we do have to memorize. I squared equals what? Negative 1, right? When something equals something in math, when something is something in math, we can put them in each other's place whenever we want. And negative 1 is way more useful to us than I squared. So if I have I squared, I'm taking that out and I'm putting in a negative 1. So this is actually negative 9 times negative 1. Negative times a negative is a positive. So this becomes plus 9. And that pattern will happen every single time, by the way. It'll get you to that plus number. Okay, well now it's not too bad. I have this times this, right? 3 terms times 2 terms. Let's go up here. Okay? When I have 3 terms times 2 terms, I go right to a box, right? You don't necessarily have to, but this is going to be your way of not losing anything, all right? So I have x squared, 8x, 16, and I have x squared and 9. And we're so close here. We just have to do this multiplication and we're done, okay? One at a time, I do these. And just be careful. Like yesterday, I did the classic mistake of I added these two. in the bottom box in one of my classes, right? It's so easy. You get on a roll and you let your brain go on autopilot. Just think every single time, what am I doing? I'm multiplying, right? X squared times x squared, that's x to the 4th. X squared times 8x squared, that's 8x to the 3rd. 16 times x squared, that's 16x squared. X squared times 9, 9x squared. 9 times 8x, 72x. And then 9 times 16 is 144. Now, remember, with these boxes, we don't get as lucky with those diagonal like terms. You kind of just got to do a little scan for like terms. If you do that, the only like terms are these two. Everything else is going to stick around, right? It doesn't have a like term. Okay? So we bring it all together. That means f of x equals x to the 4th, 8x to the 3rd. 9x squared plus 16x squared is 25x squared plus 72x plus 144. And that big thing is your answer, right? The thing I love about the end of a unit is look at this skill that we have. We can come up with random roots, and we can write a quartic function for those roots. That's pretty powerful knowledge at this point, right? You have come a long way from not even knowing what a root was, right? So that is where we've gotten to knowledge-wise, and this is like the end boss, right? And then today we add one little piece that we have not really addressed yet, okay? All right, so the rest of these are some element of that. The only difference with this one is you needed to know the missing root was negative square root of 5. And then you needed to use the same exact process. And you needed to multiply at some point a radical times a radical. You need to remember how to do that, okay? Otherwise, this is your process, the same thing.
I got confused that the same process that you could use for a radical times a radical would be with the imaginary I, and so that's why.
So I will say that there's one little piece in here with this one that's a little different. You need to know that the square root of 5 times negative square root of 5, like that's the only thing that'll be different in this one. Like at some point you'll do this math. And you got to remember the square root of a radical times itself is always just the number underneath, right? So it's 5, and then you have a positive times a negative, so it's minus 5.
Yeah, I thought it was the same thing for the I.
No, so that's why we, like I say it all the time, like we got to think about what's happening, not try to remember the step, right? Why are we doing what we're doing? Like what is happening? Oh, square roots times each other, they cancel, and then I have positive times negative, that's negative. Here, oh, I squared, that's always negative. Like if you're thinking through it, instead of just like what was the step, you'll be less likely to mix the steps up, okay? All right, so I think that's where we're going to go for the homework. Unless there's somebody who has like one that I couldn't even set it up, I just kind of want to know how to set it up. I'll talk through that momentarily. Otherwise, we're going to go to the notes. Anybody have one that they couldn't set up and they just kind of want to know how to set it up? What's that? Okay, so 10. So here, let me ask you a question. This didn't confuse you, did it? In my other class, somebody thought this was I, and they couldn't do the problem because they thought it was I. No, that's just like basically like a comma, right? This is the thing, this is the root. Okay, so it's asking you to solve this, right? You know a root, therefore you know a factor, therefore you can use synthetic division to start to break it down, and then you can factor from there using quadratic knowledge. Okay, does that make sense?
But for 9, we just have like to use the
So on 9, it's actually the same problem, but the root is given to you on a graph, right? This is not a good root. This is not. So really, we know one root. The root is 1. And then it becomes the same problem as over there. You just synthetic division, start factoring. Okay? All right, we ready for the warm-up notes, everything?